In this session, we are going to create resources like internet gateway. Okay, so this is one resource, and this resource is there in order to communicate public subnet, okay, to the internet. So that communication is possible via internet gateway. Okay, and one more source we are going to create, that is a NAT gateways. Okay, so why we have NAT gateway? NAT gateway is actually connected to we are going to mount this in a public subnet. Okay, but this is helpful in order to have a communication between private and internet. Okay, private subnet and internet. Okay, so here access is possible from private subnet to internet. Okay, but outsider user cannot access a public subnet. Okay, so that is possible with the help of NAT gateway. Okay, so internet gateway is there in order to communicate public subnet to internet. Okay, and NAT gateways are utilized in order to have connection of private subnet to the internet, and this is required because we want to update software. Okay, so in that case there is need of internet. Okay, so that is possible via NAT gateway. So these are two resources. Okay, now apart of this, there is one more resource required, that is called as elastic IP. Okay, so whenever there is NAT gateway, okay, it is always associated with elastic IP. Okay, so friends, do remember, without elastic IP we cannot create NAT gateways. Okay, so this is our third resource. Okay, now in the previous session we have created public subnet. See, this was our architecture, VPC architecture. Okay, so this is our public server, this is private server, and this is in within VPC, and we have created public server in one elastic one availability zone. Another private server is connected, developed, or we can say it is created in US East 1B availability zone. Okay, so we have done this. Okay, now if you see the code for the same, say this was the script in order to create VPC. Okay, and two subnets. Okay, done. Now in the same file, I am going to, in the same folder, I am going to create one folder called as internet gateway. Okay, NAT gateway. Okay, .tf. Okay, friends, so this is our script. Okay, see the name of the script. Okay, let me zoom out this. Okay, so this is internet gateway NAT gateway.tf. Okay, so we are going to create one file here. Okay, now already there is one file, okay, which creates VPC and subnet. Okay, friends, and here we have internet gateway and NAT gateway. So if you run terraform command from here, then VPC is created. With VPC there will be creation of subnets. Okay, and along with this there is internet gateway as well as NAT gateway. So whatever TF file is there, okay, so all, if we apply terraform apply command, okay, then it is going to create all resources, okay, which is available in this folder. So simultaneously you can create VPC, subnet, internet gateway, NAT gateway as well. Okay, friends, any doubt? Now since we have provided here resource block, okay, already in this folder resource block is there, so in this new file need not to write a resource block. Okay, if we provide sorry, not resource block, that is actually provider block. Okay, this is for AWS. Okay, so this provider block need not to write over here again. Okay, friends. So what is our need? What is our need? We want to have internet gateway. Okay, we want to create internet gateway. We want to create NAT gateway, and NAT gateway is always associated with elastic IP. So we have to create this resource as well. Okay, so again we are creating three resource. Okay, in the previous session also we have created three resources. Okay, any doubts in this? Actually, I forgot to upload lectures. Okay, VPC theory lecture and previous lecture. Okay, so definitely after this session I will upload today only. Okay, friends. So what we do here, okay, we are going to use terraform documentation. Okay, so we have terraform documentation for AWS. Okay, okay, so first we create internet gateway. Okay, so let us first create internet gateway. Okay, so for that we write internet gateway is present in VPC. Okay, so if we write internet gateway, okay, so this is a VPC. In VPCC you have this option AWS internet gateways. Okay, now friends, if you select this block, okay, so we have this resource block, okay, for internet gateway. Okay, so okay, so we copy this. Okay, now done. Now friends, here we have a resource. Whatever is resource, you have to write resource. Okay, then after this in double quote you have to write the name of resource. Okay, so here we have internet gateway, AWS internet gateway, and name of resource is always started with cloud provider. So we are using internet gateway, okay, of AWS cloud. Okay, that's why we have AWS underscore internet underscore gateway. Okay, and this is the name. Okay, this is the name of our internet gateway. So this is a reference name. So let us write IGW. Okay, and here a tag you can give any tag. Say, let us say it is IGW only. Okay, so that's it. And one more thing, see, in curvilinear bracket, okay, in curly bracket, not curvilinear, in curly bracket, okay, there is, this is called as body. So whatever information which should be associated with internet gateway, you have to write within this curly bracket. So here we have written name. Okay, we have given tag. Okay, tag may be you can provide n number of tags. So that's why again there is curly bracket. Okay, and here we have to provide VPC ID. Okay, so internet gateway is always connected to VPC. Okay, it should be always connected to VPC. Okay, so here we give VPC ID, and yesterday I told you students, we want to, whenever we want to give ID, so we write AWS VPC, okay, and then the name of VPC. So if you go to this VPC -sn.tf, okay, so if you move to this, then see the name of our file is VPC demo. Okay, so way back to our internet gateway file. Okay, and instead of here main, okay, I will write VPC demo. Okay, .id. Okay, so this is a way of providing ID. Okay, So that means this internet gateway automatically connected to this VPC. Okay, VPC demo. Okay, so this is our one resource. Okay, do you have any doubt here? Okay, so now let us move to next resource. Okay, now we first give a resource for IP, elastic IP. Okay, because if you search for NAT gateway, see what happened. If we search for NAT gateway, okay, see this is AWS NAT gateway. Okay, so if you see this, here we have allocation ID, and here it is given AWS EIP. So EIP, that is elastic IP, is required. Okay, so let us first create elastic IP, and then we think about NAT gateway. Okay, so in this navigation panel, in this search panel, okay, we type elastic IP. Okay. So here we have elastic IP. You can search EIP. Okay, let us search for EIP. Say this AWS EIP. Okay, so here we have elastic IP resource. Okay, so for that, this is our resource block. Okay, for elastic IP. Okay, so let us copy paste this. Okay, so this is single EIP associated with an instance. Actually, we do not want to connect with instance, so forget this. Okay, we want to connect this with network. Okay, we want to create this with VPC, within VPC. So forget this. So let us copy this. Okay, now here.
हेलो कपिल सर।
हाँ
सर यहाँ राउट टेबल तो आप क्रिएट नहीं किए हो कल। सबनेट एक प्राइवेट पब्लिक सबनेट के लिए तो राउट टेबल क्रिएट करना ही होगा ना।
हाँ करेक्ट। तो हम क्या करेंगे, व्हाट वी आर गोइंग टू डू, सी whenever we create route table, okay, we create one route table for private subnet, okay, and one route table for public subnet, correct?
यस
So
सर।
in public subnet we have to specify internet gateway, is that right?
यस यस सर।
So that's why first I am creating internet gateway. Okay, because what happened if we created first route table, okay, then again after creation of resource of internet gateway, again you have to go to file of route table, okay, and you have to mention over there your internet gateway. Okay,
यस
so
सर यस सर।
so that means you have to do work twice in the same file. So that's why first I'm creating internet gateway, NAT gateway, okay, and then we move to route table. Okay, so in what happened in console, immediately after subnet I think there is route table. So immediately after creating subnet we move to route table, okay, and then we create internet gateway, and again we come back to route table, and in that we have made changes. Okay, so that is also possible. It is always good practice to create first internet gateway. For if we require NAT gateway, then we create NAT gateway. Otherwise, sometimes NAT gateway is not required. Okay, but in organization, NAT gateway is there. Okay, so that's why first I'm creating internet gateway and NAT gateway. Okay, and then we go to route table. Okay, clear?
यस सर।
Okay, so friends, see we have this. We want to create within VPC. Okay, so here we have subnet ID. Okay, so this is not required because we direct connect to VPC. Okay, so So here we have AWS IP. Okay, here we have, okay, so we can copy this. Okay, resource AWS. Here we have two. Okay, so this is okay. Actually, there are two values are given. That means two resources, two AIP are created. Okay, name of first EIP is one, name of second is two. Okay, so you can copy any one, no doubt. Okay, and we want to create within VPC. That's why I'm using this. Okay, so this is for subnet. Okay, and this is for instance. Okay, so we want to associate EIP only to our NAT gateway. So that's why I am not taking this resource as well as this resource where subnet ID is mentioned. Okay, and we are not defining NACL also. Okay, network interface also. Okay, so we can remove that part. Okay, so friends, okay, so let us move back to this. Okay, our VS Code file. Okay, and paste over here. Okay, so see here we have resource AWS EIP. Okay, so this is the resource name and this is the name of resource. So let us say it is EIP, capital EIP. Okay, so this is the resource name. VPC here given it is true. Okay, so whatever VPC is present here, okay, it is attached with that VPC. Okay, so just write true. Okay, need not to do any changes. Okay, because we have copy paste this. Okay, so need not to think about this. So if you do not want to associate this EIP to VPC, then here you can write false. Okay, that's it. Okay, so okay, so this is VPC. Okay, it is true. Okay, then we have network interface. So that is again one more resource. Okay, but we are not thinking about this resource here. Okay, so forget this and need not to associate with private IP also. You can provide this option also, but I'm not going to give this option. Okay, so that's it, friends. Okay, now here we have VPC, this is EIP. Now here you can give tag or direct you can write a name like this. Okay, so you can give name. Okay, name you can write say EIP. Okay, so that's it. So it is the name of EIP. Okay, and this is reference name and this is within VPC. Okay, so that's it. Okay, so we have this elastic IP. Okay, that is for NAT gateway. Okay, so now let us we move towards again our terraform documentation and here we write NAT gateways. Okay, so NAT. Okay, so this is AWS NAT gateway and just copy paste this. Okay, here tag is also given. Okay, so friends, copy this one. Okay, okay, so press enter. Okay, so this is our third resource, AWS NAT gateway, and here reference is given example. So let us say this is NAT gateway. Okay, NAT GW, and we give tag, keep tag as it is GW NAT. So this is reflecting in our AWS console. Okay, so that's it. And here see allocation ID. So as I told you, EIP is required for NAT gateway, and this is EIP. So here we write AWS underscore EIP and here we write reference name. Whenever you provide IP, okay, you have to give a reference name. Here reference name we have provided EIP. Okay, clear? So this is our reference name AWS underscore EIP dot EIP dot ID. Okay, and here subnet ID. So tell me which subnet should I consider? Should I take private subnet or public subnet?
Sir, public.
Friends, NAT gateway is always mounted in public subnet. Okay, because what is the reason behind this? Because private subnet cannot communicate directly with internet. Okay, but public subnet can communicate with internet directly. Okay, and there is provision for internet via internet gateway. So internet gateway is there. Okay, for our public subnets. Okay, so that's why we have this. Okay, NAT gateway is always placed in public subnet. Okay, in route table we do modification, we give route for in private route table. Okay, but when we create, okay, we have to associate with public subnet. Okay, so go to our VPC file. Okay, and see the name of what is name of public subnet. See, this is public subnet, so I will copy this name. Okay, okay, so here, okay, here instead of example, okay, so we write public subnet dot id. Okay, so that's it, and we have NAT gateway name tag as it is. Okay, friends, so that's it. Okay, now here if we run terraform command, okay, then it will create VPC, it will create subnet, it will create internet gateway, it will create NAT gateway, it will create EIP also. Okay, any queries? Okay, so let me save this. So actually this is not, actually there should be one more curly bracket. Okay, that is fine. Okay, so save this. Okay, open terminal. Okay, and let us do terraform init again. Okay, then terraform apply. Okay, okay, so it is showing error name. Actually there should be some there should be space after equal to. Okay, actually name is optional. Okay, resource EIP name is EIP. So what is here? Unsupported argument. It is correct. Oh, it is showing error.
कपिल सर,
Hmm.
वो जैसे कि वो AWS इंटरनेट गेटवे में टैग्स के नीचे नेम है, वैसा होगा क्या कुछ? नेम्स के टैग्स इक्वल टू कर्ली ब्रैकेट एंड देन नेम इक्वल टू इस
हाँ
तरह
हाँ,
होगा कि?
वैसे भी कर सकते हैं, और ऐसे भी एक्चुअली होना चाहिए ऐसे भी।
एंड सर, आपने नीचे वाले नेम के लिए स्पेस प्रोवाइड किया है और उसमें तो उससे कुछ वो थोड़ी पड़ेगा। यानी नेट वाला जो है उसमें आपने स्पेस के बाद नेम लिखा है और 10th वाले लाइन पे आपने स्टार्टिंग से, तो उसके कारण तो कुछ एरर नहीं
यहाँ भी
होगा।
स्पेस है ना, स्पेस है यहाँ भी। करली ब्रैकेट तो कंप्लीट है।
तो
यस
जो
सर वही
नेम है ना वीपीसी के नीचे नेम, उसको आप टैग्स के अंदर इंक्लूड करके देते हैं, जैसे
वैसे
यहाँ पे वीपीसी में किया था ना।
correct, that would be better and that would be great practice also. Okay, so copy. Okay. Okay, it should definitely work now. Chalo, terraform, first we do terraform plan. Okay, and without terraform plan also you can run your terraform file. Okay, so see it is showing 6 to add, 0 to change, 0 to destroy. Okay, so yesterday we created 3 resources by using this file vpc subnet. So one was VPC and we have 2 subnet, public and private subnet. So these 3, and here we have internet gateway, elastic IP and AWS gateway. So that's why it is showing 6 to add. Okay. So we have VPC, see this, we have VPC. Okay. And then we have this availability zone, which we have given for public subnet, private subnet. Okay. So let me run now terraform apply. Okay, so okay, so we press S. Okay, now resources are created, so in between I will log into my AWS account. Okay, okay. Oh my God.
Sir, it was 9, not G.
Okay. Now see, it is correct. Is it correct? 5BDNC7. Okay. Okay, friends. So let us check whether all resources are created or not. So it is still creating. Okay. Okay, so if you go to VPC, okay, so there should be 2 VPC. One is the default VPC, okay, and another is custom VPC. Actually, VPC has been not created, okay, and subnet is also there. Actually, this is Ohio region.
yes North Virginia region.
Friends, see VPC2. There is one NAT gateway, okay. We have 6 default subnets. So along with we have created 2. Okay, so there is route table. There is internet gateway. Okay, so we have 2 internet gateways. Okay, so one is always their default. Okay, and so let us check by clicking this your VPC. See, this is our name, VPC demo. This was our CIDR block. Okay, and we have 2 subnet, public and private. See, these are 2 private subnet. You can check here our CIDR range and availability zone also. Okay, and yesterday, friends, see, we have discussed how many subnets are there. Now see it here, it is showing 251, and here it is showing only 250. Now here actually 5 should be reserved by AWS. Now here why one more is reserved by AWS, don't know. Okay, actually there should be 251 addresses. Okay, so okay, then friends, if you go to internet gateway, okay, see this is what, this is our IGW. See, this is default, okay, where name is not there. Okay, so this is IGW, internet gateway, which we have created. Okay, this was a tag given by us. Okay, and if you see this, okay, if you see this, see it is attached with VPC demo. See this name, VPC demo. Okay, so internet gateway is attached with VPC. Then you can go to NAT gateway. If you scroll down, okay, and see here GW NAT. Okay, so this is not there. Default NAT gateway is not there. Default internet gateway is there, but default NAT gateway is not there. So when we destroy, okay, this part will be empty. Okay, and what we have created elastic IP also. Okay, so see this is EIP tag we have given. Okay, and this is IPv4 address which is given to this. Okay, so this is connected to public IP. Okay, so that's it. So it is connected to public IP, that's why it is showing private IP addresses. Okay, and it is showing in availability zone because private subnet is present in US East 1A. Okay, so that's it actually. Okay, that's it, friends. So these are resources which we have created. Okay, any doubt in this? Okay, newcomers.
No, sir.
Newcomers. Okay. Now, friends, here if we destroy this, so terraform destroy. Okay. So here, what is one benefit of destroy? If there are a lot of guys who have done VPC by using AWS console. Okay, so it is quite difficult to delete resources which we have created. Okay, because first you have to, when you delete NAT gateway, okay, it is showing error because elastic IP is associated with this. Okay, that's why first you have to detach elastic IP. Okay, then you have to delete NAT gateway, then elastic IP, then you can delete VPC. Okay, but by using destroy, okay, all resources are created in one click. Okay, so that's why terraform is very famous nowadays. Okay, so okay, this session is over, friends. Okay.